Let me start with a simple thought. Every polymer sample we analyze has a hidden story inside it. Thousands, sometimes millions of chains, all with different sizes. Gel permeation chromatography, or GPC, helps us uncover that story. But here's something many people don't realize. GPC success doesn't begin at the instrument. It begins much earlier, at the sample preparation stage. Today, I'll walk you step by step through how to prepare everything, from tough plastics to delicate biopolymers, so your results are accurate, clean, and reliable. So what exactly does GPC measure? Unlike many techniques that separate by chemistry, GPC separates purely by size, or more precisely, hydrodynamic volume. Think of it like a maze filled with tiny pores. Large polymer chains can't enter those pores, so they rush straight through. Smaller chains get delayed because they wander inside. That difference in travel time gives us molecular weight values like Mn, Mw, and pDi. But here's the catch. Even tiny dust particles or gels can completely distort these results. That's why preparation is absolutely critical. Before touching a solvent or weighing anything, I always ask one question. What exactly am I working with? Is it a tough synthetic plastic? Or a fragile biopolymer that breaks easily? Each behaves very differently. Some dissolve easily, some resist completely. Some tolerate heat, others degrade instantly. If you skip this step and guess, you'll likely end up with cloudy solutions, degraded chains, and bad data. So first, understand your polymer. Everything else depends on it. Choosing the solvent is like matchmaking. When you choose correctly, the polymer dissolves beautifully and the solution turns crystal clear. When you choose poorly, you get haze, clumps, and trouble. THF works well for many general plastics. Chloroform is great for PLA and biopolymers. DMF or DMAC handles polar systems. And stubborn polyolefins often need hot TCB. One simple rule I always follow. If the solution isn't perfectly clear, it's not ready for GPC. Now comes the part that tests your patience, dissolution. We typically work at low concentrations, around 1 to 5 milligrams per milliliter. Too concentrated, you overload the column. Too dilute, you lose sensitivity. Gentle heating is okay, but never boiling. High heat can literally cut polymer chains into smaller pieces, giving you falsely low molecular weights. Sometimes I let samples stir overnight. Good chromatography rewards patience. This step alone can save you thousands of dollars. A single dust particle is enough to clog a GPC column. And columns aren't cheap. So every solution, no exceptions, gets filtered through a 0.45 or 0.2 micron filter. And here's something important. Filter slowly, don't force it. High pressure can shear polymer chains and actually change your results. Gentle filtration protects both your sample and your instrument. Plastics can be surprisingly stubborn. Polyolefins, for example, may need very high temperatures, sometimes up to 160 degrees Celsius, just to dissolve in TCB. They may also take hours, even a full day. And during heating, bubbles form easily, which can disturb injection and baselines. So we degas carefully and make sure dissolution is complete. Plastics require persistence, but proper preparation pays off with clean, stable chromatograms. Now biopolymers are a completely different story. They're fragile. Above about 60 degrees Celsius, many start degrading rapidly. Their chains literally break apart. So we treat them gently, keep temperatures low, use dry solvents, and prepare fresh solutions just before injection. I often say, handle biopolymers like fresh fruit. Keep them cool, Use them quickly and don't stress them too much. Over the years, I've learned these lessons the hard way. Too concentrated, you get ugly, broad peaks. Cloudy solutions, aggregates that clog columns. Skipping filtration, expensive damage. Old samples, silent degradation and misleading data. Most GPC problems aren't instrument problems. They're preparation problems. Avoid these mistakes, and you'll avoid 90% of troubleshooting. So before every run, I mentally go through this checklist. Know your polymer. Choose the right solvent. Dissolve gently. Filter carefully. And inject fresh solution. If you follow these 5 steps consistently, your chromatograms will be clean, reproducible, and trustworthy. Because remember, success in GPC starts long before you press the run button. And great data always begins with great preparation.